We're going to be watching the movie 21 today. It's about the MIT, Massachusetts Institute of Technology card counting team. And they incorporated three strategies. One of them is basic strategy. You'll hear them refer to that a couple of times. Explains when to stand, when to hit, and when to double down, or when to split cards, and we'll explain what that means later. It also incorporates what they called card counting strategies so that you can tell when the deck is hot. Then there's a completely separate strategy about how to bet when you know that the deck is in your favor. Early in the movie, they'll talk about something called the game show or quiz show problem. It's based on the show Let's Make a Deal, which once upon a time was hosted by a gentleman named Monty Hall. Wayne Brady hosts it now. And what winds up happening is the game show host offers you a choice of three doors, and the one door has a car and two doors have a goat. So obviously you have a 1/3 chance of picking the right door right out of the gate, and that's 2/3 chance of losing. What would happen then is the quiz show host or the game show host would show you the goat behind one of the other doors and ask you, do you want to stick with your first choice or would you like to switch doors? The answer to the question is that you should switch because when you started out, you had a 1/3, 2/3 chance of guessing the right door on the first try. But after the quiz show host shows you the goat, you still have the 1/3, 2/3 split, but now, of course, you wouldn't pick the one that has the goat, so it would be a 1/3, 2/3 chance, 2/3 chance if you switch to the other door, and there's only one door to pick from. So I would pick the door that has the 2/3 chance, not the one that has the 1/3 chance. Here's another way of looking at it with making a systematic list. What they're saying here is the result of switching or staying after initially picking door number one. So in the first example, they said, let's pretend the car is behind door number one, and you pick door number one. So the game show host is going to show you one of the goats. If you switch, you get this goat, but if you stay, you get a car. On the second row here, they say, what if the goat is behind door number one, and that's the door you picked? Well, the game show host is going to show you the goat, and the result of switching would give you a car, and the result of staying would give you this goat. On the third row, we're going to pretend the goat is here, and this time the car is behind door number three. So if you pick door one, the game show host is going to show you the goat, and the result of switching would switch you to the car, which would be behind this door, and the result of staying would be the goat that you had initially over here. So if you take a look at that, the results of switching is two cars and one goat. That's your 2/3 chance. The result of staying gives you one car and two goats, which is your 1/3 chance of winning. So again, makes more sense to switch than it does to stay. Here's a little tree diagram explaining how that goes. They have the car location in the first one and what the host opens. So if the car is behind door number one, you have a 1/3 chance that the car is behind door number one. The host has got a 50-50 chance of whether they're going to open door two or door three. And like we talked about with our tree diagrams the other day, you're going to talk about having a 1/3 times 1/2 is a 1/6 chance of getting a car if you stay, and a goat if you switch. You're going to have a 1/3 times 1/2 or 1/6 chance of winning a car if you stay, or a goat if you switch. Likewise, across the rest of the area diagram, if the car is behind door number two, and you pick door number one, you have the host only has a choice. If you pick door one, and the car is behind door two, the host is going to have only one choice to show you door three. 1/3 times 1 is 1/3 chance. Now remember, you picked door 1. So if you stay, you get a goat. But if you switch to door 2, you get a car. Likewise here on the last one, 1/3 chance. You picked door 1, remember, and you have a 1/3 chance that the car is behind door 3. The host only has an option of showing you door 2. You have 1/3 times 1, which is a 1/3 chance of getting a goat if you pick door 1, because the car is behind door 3. And you have a 1/3 chance of getting a car. So if you switch, you have a 1/3 plus 1/3 chance of getting a car. If you switch, there's your 2/3. Someone set up an experimental probability here, and they played this game. It looks like 30 times, and if you look at this line right here, that 20 out of the 30 times you win if you switch. And on this row here, it looks like 10 out of the 30 times you win by staying. This is an experimental probability. All of this stuff before that we did here were theoretical probabilities using the formulas. This was an example of a computer simulation. Experimental probability. All right, let's talk a little basic strategy here on how to play blackjack. Here's what happens. You get 2 cards. Dealer has 2 cards, but only 1 card is showing. And you have a choice based on the card that the dealer has showing and the cards that you have. You have a choice of whether or not you want to stand, which means you're just going to play the cards that you have. You're not going to take any more cards. You can hit, which means you ask the dealer to give you another card. You can double down, which means you double your bet, but if you do that, you only get 1 more card. And the other option is you can split any pair and basically play 2 hands. It costs you twice the money, but now if you have a couple of cards you'd like to split and play 2 hands, you can do that. So here's how it works. If you, the player, get a 5 and an 8. 5 plus 8 is 13. And the dealer has a 6 showing. You just follow the chart down like this. And what that says is if you have 13 and the dealer has a 6, that you should stand. You should not take any more cards. Face cards are worth 10. So let's say you have a jack and a 3. So as a player, if you have a jack and a 3, that's 13. And let's say the dealer has a 9 showing. You just follow it down here and follow it across there. If the player has 13 and the dealer has 9, the player should hit or ask for another card. If the player has 11 and the dealer has a 9 showing, you were to follow that down. Player has 11, dealer has 9, you should double. Now what that means is you double your bet, but you only get 1 more card. And if you look through the deck, that there's 4 2s and 4 3s and right on up the line all the way to 10s, but there's 4 10s, 4 jacks, 4 queens, 4 kings. So you're way more likely to get something that's worth 10 than you are anything else. So that's why you double in this little scenario, because if you have 11, chances are you're going to get a 10. 11 plus 10 gives you 21, and the dealer would have 9. The best they could have is if they flipped up an ace, which would give them 20, or even flip up a 10, which would be 19. So you're best off in those scenarios. If the player has 11, you should double your bet. You only get 1 more card, unless, of course, the dealer is showing an ace. On the other side of the card, let's talk about pairs. Let's say if you had a pair of 8s. Well, 8 plus 8 is 16. That's not really that good of a hand. If you're sitting over here on this table, 16, very easy to beat. But if you split those, again, it's going to cost you, you're going to have to double your bet in order to play 2 hands. Now you can play 2 8s. Well, chances are strongest, like I said earlier, that you're going to get another card that's worth 10. Well, 8 plus 10 is a pretty good hand. That's 18. So anytime you have like a pair of 8s, you should double your bet and split them and play 2 hands. And you can keep taking cards however much you need, but chances are strong you're going to wind up with 2 hands that are worth 18 instead of having the 1 hand that's worth 16, which really isn't that good of a hand. You'll see in the movie that they have their card counting strategy here, and they explain this in the movie that small cards are worth 1. So if those cards are removed from the deck because you played them, then that means there's a lot of big cards left. So if small cards have been played, they're still in the deck, that's a +1, that's for you. If big cards have been played, that means they're no longer in the deck, and that's a -1, that's bad for you. And the cards in the middle are neutral. So basically what happens, the player keeps track, and when the deck gets hot, they start betting big. Part of their system was the communication, so they had one person sitting at the table betting the table minimum, a very small bet, but keeping track. And then when the deck got hot, they would fold their arms, and then the high roller would come in and bet really big. And they had to communicate what the count was so they could keep a running total as they're going and know how to adjust their bet. So communicating that count is how they kept track. With eggs was like 12, and sweet was 16, and 17 was magazine, and they would work these sayings into whatever the sentence was to communicate the count to their partner. So somebody set up a computer program so that they could play this game. They could play 500 hands of blackjack 10,000 times. And they kept track if they just used the basic strategy, not counting, or apparently there's a Thorpe and a Braun and the MIT blackjack and high-low strategies. And so somebody kept track of what all those things were. So what happened here, if you don't count that 10,000 trials of 500 hands, that's 5 million games of cards, that you are going to lose 10.47 chips. And I don't really know what that means. If it's a $5 table, does that mean you lose 10 times 5, $50 on average? I don't really know what that means. But the important part is, as you work your way up the ladder here, that if you can use the Thorpe strategy, now you're still going to lose 7.59 chips. So I don't know if that's 7 times like a $5 chip, which is going to be $35 on average of playing 500 hands 10,000 times. And working your way up the list, this is the Braun strategy. Again, losing 5, almost 6 chips times 5, so that's going to be losing $30. Chain $5 table, 500 hands. Until you get into the MIT blackjack team is before you can even really reasonably expect to win considerably. And that's why in the movie they say, we're not gambling, this is math, we're going to win. Now really, that's like a $5 chip times 55.55, so you're going to win $2.50. So it's not like you're, really going to rake in the dough, but you have to realize they showed in the movie these people played a lot. Also, I want you to realize as you look at these things that look at the spread on these things. So this is kind of your bell curve, and we'll talk about that when we get into stats. And yes, the average or the mean is going to be, oops, I missed, here at 10.41. and realize you're probably going to lose, reasonably. There's something here called the standard deviation, which we'll talk about again in stats, you know, between 50 and maybe 25 chips. That's going to happen about 2/3 or 68% of the time. Um, if you use the other strategy, here I just backed you up. If you use the other strategy, and the standard deviation would be about here on this strategy, you could lose as many as, probably 125 chips, or maybe win as many as 110. So it's a little bit risky. You could lose a lot more. You could win more too. And as we work our way through it, same deal on this one. Actually, this blue bronze strategy is probably not a bad one because the standard deviation would be in this neighborhood. Could expect to lose maybe 50 to 75 chips, but win maybe 50 to 75 chips, 68% of the time. And last but not least, the MIT Blackjack team is out here. Standard deviation would be in this neighborhood. So you could expect to lose about 125 to 150, but you could win as much as 100. Your average is still going to be in the positive. If you look at this green high-low strategy, quite a bit riskier deal. Of course, your average is going to be higher than most, but your standard deviation is going to be probably out in this neighborhood. You could lose as much as 150 or win as much as like maybe 175. So quite a bit riskier strategies as you work your way up this list here. The safest bet, you're going to lose 10 chips or lose 50 bucks. So like we talked about before, gambling is kind of a personal preference. You have to decide if the number of hours of entertainment that you gain is worth the 10 chips that you're going to lose, and if they're $5 chips, that'd be 50 bucks. So depends upon how long you sit and play. Is 50 bucks worth the time and entertainment that you get out of the deal? So enjoy the movie 21. Have somebody write down the time when you guys get finished. And if there's another day when I happen to be gone, then we'll finish the movie. But all the math is in the first half, and I'm not necessarily planning on watching the second half. So enjoy what you get a chance to see here, and I will see you when I get back.